to do, which is kind of related to stuff you've seen. For example, hey, look at that. What's that again? That's another triangle. And lo and behold, what's that? Yeah, right. So what happens a lot, what we like to do is revisit basically stuff we know about triangles as we continue on through this entire unit. So when we're talking about triangles, what is the sum of the interior angles in a triangle? What all three of those angles have to have? 180, yeah. The sum of these things is always going to equal 180. You okay with that? All right. Well, if we have a triangle that has 180 degrees, what happens when you have a quadrilateral? Quadrilateral just means it's got four sides. Well, the easiest way to figure out the sum of the interior angles for a quadrilateral is, well, how many triangles can you draw into it that don't overlap? Here's what I mean. If I draw this, how many triangles do you see? Two of them, right? Those triangles don't overlap, do they? What I mean by overlapping is that. Then I'd have this big triangle here that overlaps on top of the other one. So I'm talking about what are called non-overlapping triangles. So how many degrees are in a triangle? 180. So if this is 180 and that's 180, how many is in a quadrilateral? 60. Okay. So this whole idea goes on and on and on for all of our shapes. If you've got the number of sides equal to 3, we know it's 180 degrees. If the number of sides is 4, we had 2 triangles, which gave us 360. If we have, if we have 5 sides, how many triangles do you think you can draw with 5? 3, right. We draw in 3 triangles. 1, 2, 3. So you have 180, 180, 180. Well, if you have 5 sides, well, what's 180 times 3? You're going to need a calculator. Really, really badly. How much was it? 540, good. All right, if I go to 6. Shape. When you have a 6-sided one, one, two, three, 4. So if you have 6 sides, you have 6 sides, you have 4 triangles. Well, what's 180 double? Double that, what do you get? 720. So when you have 6 sides in a hexagon, you've got 720 degrees total. Do you guys know what a 7-sided one is called? There's 2 words. You have a septagon or a heptagon. All right. So names of things as we go through this stuff that you guys have to know. You have to know all the basic ones. 1 through 10 and 12. We'll talk about all of those here as we go along. What was the 5-sided one? You guys remember that? Pentagon. You might want to write something down instead of having a blank sheet of paper, because I've gone through a bunch of stuff already. You have that 5-sided is a pentagon, 6-sided is a hexagon, 7-sided is a heptagon or a septagon, depending upon where you went to school. You're going to need to know them. So we have 1, 2, 3, 4, 5 triangles. When I'm saying this n equals 6, that n value stands for number of sides. So what's 5 times 180? 900. So in a 7-sided figure, you get 900 degrees. Now, let's see if we can start figuring out what's happening In a seven-sided figure, how many triangles did we have? 5. In a six-sided figure, how many triangles did we have? In a five-sided triangle, how many did we have? In a four-sided, how many did we have? 2, and then in a three-sided, you had 1. So the relationship that's happening here, well, you go further. If I go to an 8-sided one, how many triangles do you think you're going to have? 6. Yeah, you're going to have 6 of them. With 8 sides, you'll have 6 triangles. 1, 2, 3, 4, 5, 6. If you have a 9-sided, how many figure you're going to have? 7. What's an 8-sided figure called again? What's a 9-sided? You know that one? It's close. It's a nonagon. 9-sided is a nonagon. So 9 is a nonagon. 9, bless you, 8 is the octagon. And where that would have been 6 times 180. What was 6 times 180? Was it 1080, I believe? The nonagon had 7 triangles, so it would have been 7 times 180. Which is what? 1260? Thank you. That's close. What about a 10-sided figure? You know what that's called? A what? Close. Dessa or deca? I think it's more mainly pronounced deca.
Because Dusty is that one.
Because Dessa is what?
It's a fraction.
So 10 sides, n equals 10. That's a decagon. What do you think an 11-gon is called? Or ha. Is that right? It's literally called an 11-gon.
It's also called undecagon. And then a 12-sided would be dodecagon.
Correct.
2 and 10, 1 and 10. And I hope
After a while, they got kind of lazy with the names. And you're right, that more often than not, you'll see them written as you get to an 11, just an 11-gon. But 12 is the dodecagon. So the ones that we're going to hold you guys responsible for is that you have to know all the ones that they have names. Because after you get through 12, everything else is just whatever sides it is with the word gon next to it. This is a dodecagon. What's that? 1 through 12, yeah. So if the dodecagon has 12 sides, how many triangles are going to fit in it? 10. Okay. So you'll start to see that there's going to be this pattern that develops. And that's where all this comes from. What we do is this. The sum of the interior angles of a polygon is always this. Number of sides minus 2 times 180. So the sum of the interior will always be n minus 2 times 180. Where the n minus 2 comes from the number of sides subtract 2, and that's how many triangles it is. So if you have I want to find the sum of a 30-gon. Well, how many sides is there in a 30-gon? 30, so your n is 30, yeah. So the sum of this would equal 30 minus 2 times the 180. And you press buttons on your thumb. When you do this, you can quite literally just throw it in as is. Parentheses, 30 minus 2 times 180. You get that. All right. So it works. It all goes out real nice and clean for you, okay? Yeah.
Good, that's very insane.
All right, and that's part of it. And it works the same way, is that you can be given the sum of the interior, find out how many sides there are. Or but for tobacco's.
Can I see an example of that?
No. Oh, actually, we'll get to that because they do that first. Okay, this one doesn't. No, at the end of the section. They don't do it right away. Actually, pull it up. For example, if I have want you guys to try these two. There's an interior angle, and then there's an exterior angle. Take a second to figure out the value, how many sides there are. Take a second to figure out how many sides there are. So let's see. If you have an interior angle at 175.2, remember, draw your generic. That means your outside angle is what? 4.8? Bless you. Means your outside angle is 4.8. Which means 360 divided by something equal 4.8. So, change-o, you get 360 divided by 4.8, you get how many sides? 75, good. All right. That's the idea. And the other one, they're giving you the exterior angle. If they give you the exterior angle, do you have to do extra work? No. If you know the exterior angle is 45, well then you write it out. 360 divided by something equal 45. That something was. Over time, as we get to do more and more of these things, you guys will start to remember that hexagons, they always measure the same degrees. Octagons, they always have the same degree measures. It shows up over and over and over and over again. Right? Now, what happens if you get something that looks like this then? Oh, yeah. Sometimes what we're looking at here with these regular polygons, that means that all your sides and all your angles are the same. Sometimes you might not have a regular polygon. Sometimes you just have a regular, just a boring polygon, what's called a convex polygon. It doesn't necessarily mean that all your sides and angles are the same, but is there enough information there so you can figure out what the missing angle would be? Well, how many angles are there in this problem? There's 4 of them, which means how many sides are there? Huh? If you have 4 angles, how many sides are you going to have? 4. Oh. So if I'm trying to figure out what the last angle equals, well, if I have 4 sides, find the sum of the interior, 4 minus 2 times 180. That means all 4 of those have to add up to equal how much? 60. So 120 plus 85 plus 53, 8, 7, 5, what is it? 258, so 360, subtract the 258, what'd you get? 102. Okay? It's not that the math is going to be difficult. What's going to be difficult is you're going to hit the wrong button on your calculator between a 3 or a 2. Just press the wrong button. Okay? This stuff is relatively straightforward. Excuse me. All right? That's. Will you see algebra with this? Yes. Algebra shows back up with all this as well because it could still be an angle measure can be given to you as x plus 6. Oh no. Let's put it all back together. Let me show you an example. Let's see. I thought I had an example. I did not. For example, you can throw in values of x. Solve for x. Okay? have to solve for x, first thing you got to do is figure out what do all of them have to add up to equal. Well, how many of them are there? There's 5 of them. That means how many sides will there be? 5. So you have to do your 5 minus 2 times 180. You get 540. Good. So you know that all 5 of those angles have to add up to equal 540. Well, 3x plus 64 plus 2x plus 86 plus 110. And this winds up being a giant combined like terms problem. 5x, 64 and 1 is 130, I believe. 130, 130, 110 is 240. Okay. And you get that. And you wind up with a very quick 2-step equation. Was it 260? Oh, yeah, I didn't carry the 1. Sorry. 260, thank you. So subtract that over, you get what? 5x then is 280. Thank you. You get x is 56. Is that right? It's not real tough math here, guys. It's kind of a nice little thing towards the last bit of the semester here. And like, I don't know if I mentioned this before, our previous textbook brought this section in about the middle of second semester after we did a bunch of trigonometry. So then you could hide in there, right triangle trig and all that. This textbook does it prior to it, so it won't become as complex. I guess it's something different. We haven't tried it like that before. Let's see. Take a second, figure out how many sides do those two have. If those are the sum, figure out how many sides there are. Excuse me. Question. So we do that, we get what? Excuse me. N minus. Or did you guys just do n equals 2160 divided by 180 plus 2? Did you guys write? Which way did you guys write it out? Is the first one or the second one? Either one is fine. It works. All right. Either one works out. Let's see here. If you do it this way, 0s, 3, 72, 9, and 6. That's what? 12, 14. Did you get 14 for that? Okay. What's that? Yeah, it's the same thing. You take 2160 divided by 180, and then add 2. So basically, what I'm doing is I'm skipping writing this out by using this formula here, because this formula is the worked out version of this. It's just like we were saying. So if I wanted to isolate n, whatever that is, I would divide this by 180, and that goes away, and then I would add the 2, and that's my literal equation to solve for it. It's just a shortcut. Do I have to do the 32 for you? Yeah, that's pretty easy on that one. Those already. So find find the number of sides of each individual interior angle is 144. How many sides does it have if the regular polygon has 144 degrees for each inside angle? Remember, is it easier to work with the inside or the outside? Outside. So draw 3 sides. If the inside is 144, what's the outside? 36. Which means 360 divided by something equals 36. 360 divided by 36. No, 10 is the number of sides. If you're working with your exterior angles, that's how it works. Another quick little shortcut to remind yourselves of, you want to write this one down too. If you take 360 divided by the exterior angle, it always equals number of sides. If you're looking at for regular polygons, that's the shortcut if you want to remember that too. So 360 divided by your outside angle will always equal the number of sides. It's a lot of little subtle nuances with the formulas and stuff here. They're not tough to use. There's just a bunch of different ways of doing things. Okay. So let's see here. I think I wrote it in. I did. Do these, please.